Hello students, कैसे हैं आप लोग? मेरा नाम शीतल ठाकुर है and I welcome you all to my channel. So in today's lecture, I'm going to cover chapter number 3, that is Factors of the Locality of this book, Principles and Practices of Silviculture, written by LS Khanna. This is a very important book which every forestry student should know, as well as the students who wants to select forestry as their optional subject for the UPSC, State Public Services, Indian Forest Services, State Forest Services, ACFRE for examinations, etc. Why this book is important? Because this book provides the basic knowledge of the forestry. Okay, so if you want to study forestry and learn the concepts of the forestry, then this is a very must book you must have idea about. Okay, so the chapter 1 and chapter 2 of this book I have already covered in my previous lecture, as well as the introductory part of this chapter, that is the factors of the locality, in which I have told what are the factors of the locality, classification of the factors of the locality, definition of the factors of the locality. I have already covered in my previous lectures. So if you want to go through those lectures, I will provide the link in description box, or you can click on the I button and go through all of them. Okay, so in today's lecture I'm going to cover the climatic factors. In my previous lecture, I have told you the classification of the factors of the locality into 4 broad categories. That is the climatic factors, topographic factors, edaphic factors, and biotic factors. Okay, so all these factors, they are described very broadly in this book. Okay, so I'm going to cover these factors one by one. So first of all, in today's lecture, I'm going to cover climatic factors. Under this, I will be covering only the solar radiations. Okay, so under this, we are going to cover light, temperature, effect of the extreme cold temperatures. Under this, we will be studying frost and snow. Then we are going to cover the effect of the extremely hot temperatures. So without wasting further time, let's start our lecture. So what are the climatic factors? Okay, so before understanding climatic factors, you must know the climate. Okay, so climate is defined as the average weather condition which is prevalent in any locality. Okay, so what are the weather condition? Weather condition is the short-term state of the atmosphere. For example, if it is raining outside for 2 to 3 days, then the weather condition for these 2 to 3 days will be the rainy weather condition. When such kind of weather conditions, they are prevalent on an average throughout the year, then it will define the climate of that locality. Okay, you can take the example of north and south poles, where the average weather conditions which is prevalent throughout the year is the cold weather conditions. Okay, so therefore we can say that the climate of the north and south pole is the cold climate. Okay, so the climate depends on the various meteorological and weather conditions. Important of them are the solar radiation, moisture, and wind. Okay, so the factors of the locality are defined as the light, atmospheric temperature, pressure, humidity, wind, and other features of the climate, regional, local, seasonal, that influence the vegetation of a particular place, is known as the factors of the is known as the climatic factors. Okay, so here is the classification of climatic factors into solar radiation, which is further classified under the light, heat, and temperature. And then we have the moisture and then the wind. Okay, so in today's lecture, I am going to cover solar radiation. In this, we will be covering light, heat, and temperature. Okay, so let's talk about the solar radiation. Okay, as we all know that sun is the ultimate source of energy to the earth. Okay, so the energy which is received by the earth from the sun is known as solar radiations. Okay, the earth receives these energies in the form of the electromagnetic radiations. Okay, so the total amount of the energies received by the earth from the sun is categorized under ultraviolet radiations, which is received only 1%, then the visible spectrum received 39%, and the infrared radiations received by the earth from sun is 60%. Okay, so this is the classification or the composition of the solar radiations received by the earth. Okay, so this visible spectrum range is the range of electromagnetic radiation which is visible to the human eye. Okay, so it ranges from 400 to 700 millimicrons, and below this range will be the ultraviolet radiations, and above this range will be the infrared radiations. Okay, so the maximum amount of the solar radiation occur in the green and the yellow regions of the visible spectrum, and the intensity of solar radiation is generally measured by the heat generated by it. Okay, so as the energies which are radiated by the sun, when they move towards the earth, they do not get completely absorbed inside the earth. Okay, so here is the atmosphere, which is a layer present outside the outside our earth. Okay, so some of these radiations, they won't even penetrate this atmosphere, while some of them get absorbed by the gases present in the atmosphere, while some of them they get absorbed by the clouds present inside this atmosphere, while some of these radiations they get reflected back, and while some other radiations they get trapped inside the atmosphere. Okay, so they keep on trapping inside the atmosphere, and they result in the important phenomena which is known as the greenhouse effect. Okay, so this greenhouse effect is very important, because due to this effect, the temperature which is required for our existence and for the survival, it is maintained by this phenomena known as greenhouse effect. Okay, so if this phenomena was not there, if this phenomena was absent, then our earth could be too cold that it won't favor the survival of the living things. Okay, so life won't be possible without this phenomena. So this is very important phenomena. Okay, so the different surfaces has the different potential to reflect the light back. Okay, so this reflection of the light back is known as the albedo. Okay, so here you can see it is estimated that 42% of the incoming radiations, they are reflected back. Okay, so this phenomena of the reflection back of the incoming radiation is known as albedo. Okay, so this varies with the substances to substances. Okay, different substances has different potential to reflect the light back. Okay, so it is observed highest in case of the fresh snow or the ice. Okay, it is 85 to 95% in case of the fresh snow. Then it is about 60% in case of the sea ice, while it is about 50 to 90% for the white clouds. Okay, here you can see that the soil and exposed ground has 5 to 30% of the albedo, and forests have 5 to 20% of the albedo, and sands have 20 to 40% of albedo, and grass and crops have 10 to 25% of albedo, and it is minimum in case for the oceans. Okay, it is about 5 to 10%. Therefore, oceans are known as the heat sink because they absorb the incoming solar radiation and reflect only about 5 to 10% of it back. Okay, so the solar radiation which are reaching to the Earth's surface, they are further affected by these factors. Okay, they are the latitude, altitude, season of the year, time of the day. Okay, so let's understand latitude first of all. Okay, so what is latitude? Latitude is nothing but it is the distance from the equator towards the north and south pole. Okay, so this is the south pole, this is north pole, and the line passing through the center of the Earth is known as equator. Okay, so the distance from the equator towards the north and the south is known as latitude. Okay, so here from the diagram you can clearly see this is sun. Okay, so the energies which received by the equator, they are the overhead, and okay, they are spread over the narrower area. As a result, the intensity of the solar radiation in this equator region is very high, while when we move towards the north and the south pole, okay, so this spread of the incoming radiation, it is increased to the larger area. As a result, the intensity of the solar radiation decreases when we move towards the north and south. Okay, therefore with the increase in latitude, the solar radiation intensity keeps on decreasing. Okay, next we have altitude. Okay, altitude is nothing but it is a distance of a particular point from the standard referral point. Suppose we are taking the mean sea level as the standard referral point. Okay, so the distance of a particular point from the mean sea level will be the altitude of that place. Okay, so with the increase in altitude, the solar radiation intensity increases because as the altitude increases, the atmospheric pressure decreases. Therefore, the intensity of the solar radiation increases with the increase in altitude. Okay, so next we have the season of the year. Okay, here I have provided you the diagram. You can clearly see that the position of our Earth is different with the different season. Okay, therefore the radiations received by the Earth is different for the different season. As a result, it has the different intensities in the different season. Moreover, the radiations received by the north and southern hemisphere is also completely different. Okay, as a result, there is the complete different season in the north and south hemisphere. Okay, from this image you can see that the north pole is receiving direct overhead sunlight, while the southern hemisphere is receiving the oblique sunlight. Okay, therefore there is summer in north pole and winter in the south pole, while in this case it is completely opposite. Here the southern pole is receiving direct overhead sunlight, while the northern pole is receiving, or the northern hemisphere is receiving, the oblique light. As a result, the winter will be in the northern hemisphere and summer will be in southern hemisphere. That's why the Australia, which is located in the southern hemisphere, have the summers when there is winter in the European countries. Okay, so this is how the position of Earth varies, and the season affects the solar radiations. And next we have the time of the day. Okay, this you also might have noted that in the evening and morning time, the solar radiation intensity, they are lower. Okay, because the light received is oblique by the Earth, while during the daytime the solar radiations, they are received by the Earth, they are direct and overhead. As a result, the intensity of the solar radiation during the daytime is higher as compared to the evening and morning. So, as I already told you, under sunlight, we are going to cover light and temperature. Okay, so first of all, let's talk about light. Okay, what is light? Light is nothing but it is the part of visible spectrum that is sensitive to the retina of human eye. Okay, which is visible to human eye. Okay, so this electromagnetic radiation, which range within 400 to 720 millimicrons, is known as the light. Okay, so this is very important for the growth and development of the plants, as it helps in the formation of chlorophyll. Okay, so chlorophyll is a very important chemical compound which is responsible for the photosynthesis and the green coloration of the leaves. Okay, so from here image you can observe this discoloration. Okay, discoloration in the leaves. This is due to the absence of the light. The chlorophyll formation does not take place properly. As a result, the leaves of the tree become pale or yellowish in the color. This paling or discoloration of the leaves is known as etiolation in the leaves. Okay, so next is the functioning of the stomata. Okay, so stomata is very important structure in the cells of the plants. So this stomata helps in the exchange of the gases in the plant tissues. Okay, therefore light also have a great role in the functioning of the stomata. Okay, next is the photosynthesis. Photosynthesis is very important process by which the trees make their own food using sunlight, and they produce the oxygen, which is very important for the survival of human being. Next is the growth. Okay, so the influence of the light on the growth of the plant depends upon the quality of the light, quantity or the duration of the light, and the intensity of the light. Okay, first of all, we have the quality of the light. Quality refers to the wavelength of the light spectrum or the color of the light. Okay, so here you can see that the blue light results in the low plant growth, while the red light results in the elongation of the cell, which gives a good growth. And here you can see that the ultraviolet and the violet lights brings about the dwarf effect in the plant. This is how the quality of light affects the plant growth. Next, we have the duration of the light. Okay, so here we have the important phenomena known as photoperiodism. Okay, so in simple words, what is photoperiodism? Photoperiodism is the duration of the light to which a plant is exposed. Okay, so it affects plant growth by breaking the seed dormancy, then the germination, leaf fall, and flowering. Okay, so all these processes, they are different from species to species. For example, you can see the short days may cause the dormancy in the Populus, but not in the Juniperus. Okay, so the requirement of the photoperiod for the breaking seed dormancy, for the germination, for the leaf fall, for the flowering is different from species to species. Okay, so next we have the intensity of the light. Okay, so intensity is the amount of heat generated by the light, refers to the intensity of the light. Okay, so the amount of the dry matter produced by the plant usually increases with the increase in intensity of the light, but up to a certain point. Okay, therefore the moderate intensities is required for the functioning of the plants. Okay, so the intensity of light should be moderate in quantity. It should not be too high or too low. Okay, it should be moderate. And in the forest trees, generally the intensity of the light required is 1 to 1.5% of the full sunlight, so that the photosynthesis gain is greater than the loss due to respiration. Okay, so as we all know कि जो photosynthesis के टाइम पे है, उस टाइम ट्री जो होता है वो खुद के लिए एनर्जी प्रोड्यूस करता है, वाइल जो रेस्पिरेशन के लिए के टाइम पे वो एनर्जी जो है वो यूज हो जाती है. ओके, सो जो हमारा फोटोसिंथेसिस का रेट है दैट शुड बी हायर देन द रेस्पिरेशन, तभी प्लांट की प्रॉपर ग्रोथ होगी. ओके, तो ये जो फोटोसिंथेसिस का रेट हायर रहे रेस्पिरेशन से, फॉर दैट 1 to 1.5% ऑफ फुल सनलाइट इज रिक्वायर्ड फॉर द ग्रोथ ऑफ द प्लांट्स. Okay, so next we have the form and quality of the tree. How does the light influence the form and quality of the tree? Suppose this is a tree, so the upper branchy part of this tree will not allow the lower branchy parts to receive light. Okay, so the light received by the lower branches will be very less. As a result, these lower branches will fall off, and the crown will be confined to the upper part only, and this portion of the stem will be free from the branches, which results in the clean bole. Okay, this is how the light influences the form and quality of the trees. Okay, so next is the species stratification, size and structures of the leaf. Okay, so species stratification depends on the light. Okay, suppose the trees, they are present in the various canopies in the forests. Okay, so the trees which are present in the top canopy, okay, so top story, they will receive the higher amount of the sunlight. As a result, their growth will be higher and they will attain the top canopy, while the trees below this will receive the lesser amount of the sunlight, and the tree in the lower strata will receive very few amount of the light. As a result, these tree will die, and some of them will survive and they will stay only in the lower strata of the canopy. Okay, this results in the stratification of the species. Okay, and size and structure of the leaf is also influenced by the light. Okay, as I told you, in the chlorophyll formation is influenced by the light. As a result, the size and structure also influenced by the light. Okay, so here you can see this is the mosaic in the acer leaves. Acer is a tree whose leaf, you can see this here. This is the discoloration, it's not the discoloration, this is the color variation in the various parts of the leaves. Okay, so why this color variation is there in these leaves? This is due to the variation in the light intensities received by a particular part. Okay, so here the light intensity is higher, and here is the light intensity is lower. As a result, this portion is green and this portion is of the other color. Okay, so next we have the classification of the trees based on the requirement of the light. Okay, so based on the light requirement, the tree species are classified as the light demander, shade bearer, and the shade demander. Okay, so light demander are the tree species that requires abundant of the light for its best development. Okay, so light demander species needs to be planted and needs the proper light. Okay, higher amount of the light for their proper growth and development. Next is the shade bearer trees. Shade bearer trees can sustain or can survive in the when the light availability is little lesser. Okay, so the species which are capable of the persisting and developing under the shades, they are known as the shade bearer. Okay, then we have the shade demander. Shade demander are the species which at least in its earlier stages needs some degree of the shade for its normal development. Okay, so those tree species which demands for the shade, they are known as shade demanders. Okay, so here are some examples of the tree species light demander, shade bearer, and the shade demander tree species under various kinds of the forest. Okay, so you can go through these species, and you can pause this video and you can also write it down if you want to. Okay, so first of all, we have the moist temperate forest. Here the light demander species is Pinus voliciana and Populus ciliata. Shade bearer species are the Piscius smithiana, Cedrus deodara, Cypressus tortuosa, and Quercus dilatata. And shade bearer species are the Abies spindro and the Texas baccata. So you can go through these species. I cannot dictate all these. Okay, so you can pause this video and write down these tree species. Okay, so under solar radiation, we have completed light. Now let's talk about temperature. Temperature is the measure of the hotness and the coldness. There are various factors which influence the temperature. First of all, we have latitude. Latitude, as I already told you, it is the distance from equator towards the north and the south pole. Okay, so as the latitude increases, the temperature decreases with the increase in the latitude. Next is the altitude. Temperature also decreases with increase in the altitude. It has been also observed that with every 270 meter rise in altitude, there is a decrease of 1 degree centigrade in the temperature, 1 degree Celsius in the temperature. Okay, so next is the distance from the sea level. Okay, so the area or the place which is near the sea level or at the sea level or the coastal areas, they do not have temperature variations or the seasonal variations in the temperature. Okay, and their temperature is almost constant throughout the year, while the place which will be the far from sea level will have the temperature variations. Okay, and will also have the seasonal variation, seasonal temperature variations. Okay, so next is the winds. Winds also influence temperature significantly, as the southwestern monsoon, which has been brought by the winds, causes the rainfall. As a result, it decreases the temperature. Therefore, winds also plays a significant role in the temperature. Next, we have the mountains. Okay, mountains, suppose this is a mountain, okay, and wind is blowing from this direction. So the slope of this mountain facing the direction of the wind will be windward side, and opposite to this will be the leeward side. Okay, so the side which is receiving the high speed winds, the temperature at this side will be lower as compared to this leeward side. Okay, as well as the, suppose this is sun and the sunlight receiving directly. Okay, so suppose this side is receiving the direct sunlight. Okay, so the temperature here will be greater as compared to the side which is receiving the indirect sunlight. Okay, this is the reason why the northern north facing slopes are having lower temperature as compared to the south facing slope. Okay, so this is how the mountains influence the temperature. Next, we have the cloudiness. As the clouds obstruct the path of the sun, as a result, it also influences the temperature. Then the presence or essence of the vegetation. Suppose the vegetation are present in a particular area. Suppose these are the vegetation present in an area, and there is other area which is bare and do not have any vegetation or have very less vegetation as compared to this area. So the lights coming from the sun rays, they will not penetrate the ground of this area. They will be obstructed by the vegetation present in that area. As a result, the temperature of this area will be less. Okay, while the area which is exposed and do not have any vegetation present, they will be receiving the direct sunlight. As a result, the temperature will be higher as compared to the area where the vegetation is present. Okay, so next is the importance of the temperature. The importance of the temperature can be studied under the air temperature and soil temperature. First of all, we have the air temperature. How air temperature is important because it influences the various physiological activities. Okay, so that is transpiration, photosynthesis, and respiration. Okay, all these activities, they are greatly influenced by the temperature. Transpiration increases with the increase in temperature. Photosynthesis also increases with the increase in temperature up to 25 degrees Celsius. Below that, it will decrease. And respiration also increases with the increase in temperature up to 40 degrees Celsius. Next is the increase in the biological activities by helping organic matter decomposition. Okay, so greater the temperature, greater the air temperature, more will be the decomposition of organic matter, greater will be the biological or the microbiological activities. Okay, next is the it affects the enzyme activities. Okay, so enzymes also needs a particular temperature for their functioning. Okay, therefore it also influences the enzyme activities. Next is the increase in cambial activities. Okay, so cambial activities are responsible for the development in the trees, and they also needs a particular temperature for the favorable growth of the trees. Okay, so and air temperature is also essential for the germination of the seed. Okay, so seeds also need a particular temperature for their germination. Okay, therefore the air temperature has all these importance. Next is the soil temperature. So how soil temperature is important because it influences the moisture content available in the soil. Okay, so the soil temperature will have a great influence on the availability of the moisture to the plant. Okay, suppose the temperature is below 1 degree Celsius or 0 degree Celsius, the amount of the moisture present in the soil will be absorbed by the soil particles. As a result, it will not be available to the plants, and if the soil temperature is higher, then it will also not be available to the plants. Therefore, a medium temperature range in the soil is required for the proper growth and development of the plant. Next is the influence on the cambial activities. Okay, so it has been observed that if the soil is having the soil is warmer, soil is having the greater temperature, the cambial activities are greater at that place as compared to the area where the soil temperature is low. Okay, so the temperature favors the cambial activities. Okay, so next we have the classification of the vegetation based on the temperature. Okay, so here are the various zones given, that is the tropical, subtropical, temperate and alpine zones. Okay, and here is the mean annual temperature, that is tropical region will have the 24 degrees Celsius mean annual temperature, subtropical mountain zones will have 17 to 24 degrees Celsius mean annual temperature, and the temperate mountain zones will have the 7 to 17 degrees Celsius of the mean annual temperature, and the alpine or the mountain zones will have the mean annual temperature that is less than 17 degrees Celsius. Okay, so here is a mean January temperature is given for these area. Okay, so January is the coldest month, therefore the mean January temperature for the tropical zones will be over 18 degrees Celsius. For the subtropical areas will be 10 to 18 degrees Celsius. For the temperate zones it will be the 1 to 10 degrees Celsius, and for the alpine zones it will be below -1 degree Celsius. Okay, so here is the remarks. The tropical zones will have the cold seasons that are very short, या फिर उसमें होंगे ही नहीं. Okay, and there is no frost and snow observed in the tropical zones, and the subtropical zones will have cold seasons for a definite period, but they are not severe. Okay, and they may face a rare frost. Okay, then we have the temperate zones. In the temperate zones winters will be pronounced with the frost and some snow. Okay, वहाँ पे frost और snow होगी. Then the alpine zone होंगे हमारे, उनमें winter long होगी, severe होगी, और उसमें snow और frost दोनों ही observe होगी, और snow उसमें ज़्यादा पाया जाएगा. Okay, next is the effects of the temperature. Under this we are going to study the adverse effects of the temperature. Okay, so this will be studied under the effect of the excessively low temperature and the effects of the excessively high temperatures. Okay, so what are the adverse effects of the high and low temperatures? Okay, so first of all we have the effect of the excessive low temperature. Okay, so in the tropical conditions, okay, tropical zones, the temperature जब 5 डिग्री सेल्सियस से कम होगा, it may result in the chilling injuries to the plants. Okay, the injuries is caused by the excessive of the transpiration and the excess of the respiration over the photosynthesis. Okay, so the rate of the photosynthesis will be lower as compared to the respiration and the transpiration when the temperature is below 5 degrees Celsius in the tropical zones. Okay, so this will result in the killing of the plant or may break down more proteins than it synthesized. Okay, so and further, if there is more further drop in the temperature, it may result in the frost and snow. Okay, so frost and snow, they are mainly observed in the temperate zones. Okay, in the tropical zones we don't observe the frost and snow. Okay, okay, so let's study the frost first. Okay, what is frost? Frost is the chilling of air below freezing point. Okay, suppose this is the air particles present in the atmosphere. When the temperature of this air goes below the freezing point is 0 degrees Celsius. When the temperature of this air is below freezing point, then it will form the frost. Okay, depending upon the mode of occurrence, the frost can be classified as the radiation frost, pool frost and advective frost. Okay, so first of all, what is radiation frost? Radiation frost में क्या होता है? Suppose these are the air particles present in the atmosphere. Okay, and here we have the solid surface or the ground, or we have some vegetation here. Okay, so when the temperature drop down below the freezing point, the water molecules present in this air will get freezed, and these molecules will be settled down on the ground or on the vegetation. Such kind of the freezing appearance will result in the formation of the frost, like this you can see in this image and in this image. Okay, so these both images, they are of the radiation frost. Okay, so here is the radiation frost on the ground surface, and here is the radiation frost on the leaf surface. Next we have the pool frost. Pool frost में क्या होता है? Suppose we have mountain here and we have mountain here. Okay, so the air present on the mountain, they are the cooler as compared to the valleys. Okay, this air will be heavier as compared to the air present in the valleys. Okay, okay, so with the flow of the winds, these airs, they get settled down towards the valley, और जो वैली में लाइट एयर प्रेजेंट होगी और द वार्म एयर प्रेजेंट इन द वैली, दे गेट रिप्लेस्ड बाय दिस कूल एयर्स ब्लोइंग फ्रॉम द हिल्स. एज अ रिजल्ट जो हमारी वैली पे क्या होगा? वैली पे फ्रॉस्ट अकर कर जाएगी. ओके, सो दिस काइंड ऑफ फ्रॉस्ट इज नोन एज पूल फ्रॉस्ट. ओके, next we have the advective frost. Advective frost क्या होती है? When the cool airs, they are brought to a particular area, some other place by the wind. Okay, this is known as advective frost. Okay, so I couldn't find the image of the advective frost, that's why I have not given here. So you can see the image of radiation frost. First and second are the images of the radiation frost, and here is the image for the pool frost. Okay, so in this book, example for the pool frost in India is given as the Dehradun Valley, but I couldn't find the image of Dehradun Valley with the pool frost, so I have provided this image. Okay, so next we have the frost pocket. Okay, so this is a term related to the frost. Frost pocket क्या होगी? Frost pocket is an area where the cool air get accumulated. Okay, जहाँ पे cool air accumulate होगी और as a result the more frost will be formed in this particular pocket as compared to the surrounding areas. Okay, so here in this image, this you can see the occurrence of the frost at this particular place is due to the accumulation of cool air over this place. Okay, as a result this place will be having higher frost as compared to the surrounding areas. Okay, so here is the definition of all the frost: radiation frost, pool frost, and advective frost. You can pause the video and note it down. Okay, so next is the frost injuries. Okay, so how does frost cause injuries to the plants? Okay, so first of all we have the killing of the young plants and their parts. Okay, how does frost kill the young plants and their parts? Okay, so when there is the frost on the ground, it reduces the temperature greatly. As a result, the water molecules present in the soil, they are not available to the plants, they are not absorbed by the plants because they are freezed due to low temperature. And when the sunrise, the process of the transpiration occur, and at that time the process of the transpiration is much greater as compared to the moisture available to the plant. Okay, so moisture is not available to the plant and sun is draining the moisture out of the plant due to the process of transpiration. As a result, the young plants, they die. Okay, and their their parts also, they are also killed by the frost. Okay, next we have the important term is the frost heaving or frost lifting. Frost heaving or frost lifting क्या होता है? Here from the image you can see that जब हमारे पास frost present है, then it result in the expansion of the water molecules which are present in the soil. Okay, they tends to expand when they get freezed. Okay, जब हमारे पास ये generally होता है, जब water molecules freeze हो जाते हैं तो उनका volume क्या होता है? Expand हो जाता है. Okay, so due to this expansion, ये आप soil देख सकते हैं यहाँ पे, so this soil also get expand. As a result, यहाँ पे जो भी seedlings grow करनी होंगी, they will uproot it. Okay, जो young जो हमारे बड़े trees होंगे, they have their roots properly fixed in the soil, तो उनके ऊपर ज़्यादा damage नहीं होगा. But जो young seedlings होंगे जिनकी roots यहीं तक है, हमारी suppose ये young seedling यहाँ पे grow करने की कोशिश कर रही है and this heaving is taking place due to frost, तो इसकी वजह से क्या होगा? ये uproot हो जाएगा यहाँ से seedling. Okay, then we have the death of the plant and death of the plant due to the damage to the cells. Okay, so इसमें क्या होता है कि जो हमारे plant के cells होते हैं उसमें water molecules क्या होते हैं, वो they get frozen due to the low temperature. As a result, जो plant के parts होते हैं, उनकी death हो जाती है. Okay, next is the injuries to the crown poles and the sapling. This is also due to the low temperature. And next we have the frost cracks and formation of the frost cankers. Okay, so here in this image you can see this is this vertical incision is known as the frost crack. ये क्यों होता है? Because due to the low temperature, okay, present here, the molecules, water molecules in the wood gets frozen. Okay, and they try to expand themselves. As a result, इनमें cracky appearance आ जाती है and they form the frost cracks. Okay, so उसको हम क्या बोलते हैं? Frost cracks बोलते हैं. Okay, so next we have the frost canker. Okay, so here from this image you can see this is the canker. Canker कैसे होता है? जैसे हमारी suppose यहाँ पे branch उग रही है. Okay, due to frost क्या हो रही है? इसकी proper growth नहीं हो रही है and it get felled off. Okay, तो इसकी वजह से यहाँ पे जो present होगा हमारे पास ये एक type की injury जैसी रह जाएगी. It will result in the formation of the canker. Okay, और ये canker further grow करता जाएगा. Okay, तो it will result in the formation of canker. And from this image you can see there is the death of the leaves on the trees due to the presence of the frost. Here you can clearly see the death of the leaves in the trees due to the frost. Okay, so these are some frost injuries you can see in this image. Okay, so based on the tolerance of the plant to the frost, the plants are categorized into the frost hardy, moderately frost hardy, and frost tender. Okay, so the tree species which has resistance against the frost, they are known as frost hardy, and the species which has moderate resistance against the frost, they are the moderately frost hardy, and the species which get affected by the frost, they are known as the frost tender species. Here are some examples of the tree species given. You can pause the video and go through all these examples, and you can also note it down. Okay, so the factors which affects the frost resistance are classified as the internal and the external factors. Under internal factors, we have the size of the cell. So if the size of the cell is large, then it will be less resistant towards the frost. Therefore, the smaller size of the cell is required for the trees to be frost resistant. Then we have the water content. Greater the water content in the cells, more it will be frost prone. Okay, so it will not be frost resistant if the more amount of the water is present. Then we have the osmotic concentration. So greater the osmotic concentration, greater will be the plant resistant towards the frost, because the osmotic concentration will result in the lowering the freezing point of the cells. Okay, as a result, the cell will be resistant towards the frost. Then we have the permeability towards the water. Okay, so if the protoplasm is permeable to the water, then it is less likely to freeze. Therefore, it makes the cell resistant against the frost. Then we have the water binding colloids. If greater amount of the water binding colloids are present in the cell, it will not allow the water to stay free in the cells. Okay, as a result, it will increase the frost resistance and does not provide water to get freezed. Okay, so that's why presence of the water colloids will increase the frost resistance in the trees. Then we have the external factors. Under external factors, we have temperature, light, and mineral nutrition. Okay, so if the temperature is reduced gradually during the winters, it will increase the frost resistance in the trees. Okay, and we can induce this frost resistance in the nursery trees, okay, by gradually reducing the temperature below freezing point before the actual frost to come. Okay, and in nature also, if the temperature increases even for the small period, then it helps the tree to withstand against the frost. Then we have the light. Okay, lesser the tree is exposed to the light, lesser the photoperiodism, greater will be the resistance against the frost in the trees. This is due to the fact that if the light is less available to the plant, then it will not grow. Okay, so it will not lose its energy in the growth. As a result, the carbohydrates stored in the plant, they are converted into the sugar, and as a result, it increases the resistance against the frost. Then the mineral nutrition. Okay, so the nitrogen, if the greater amount of the nitrogen is available in the soil, then it will enhance the growth of the trees. Okay, as a result, it will not be resistant against the frost, while the potassium and phosphorus will make the plants frost resistant. Okay, so next is the hardening off. Hardening off is an important natural phenomena in which a plant adapts itself towards the harsh climatic conditions. Okay, so the hardening off is a natural process by which a plant becomes adapted to the drought, cold, and heat. Okay, thus in nature, when the gradual lowering of the temperature results as the approaching winter, it causes the natural hardening off in the plants against the frost injuries. Okay, so this frost hardiness can be induced by subjecting the plants to increasing lower temperature up to the freezing point. Okay, that's how we can induce the frost hardiness in the plants. Okay, so next is the protective measure against the frost. Okay, in nature, the protective measures that needs to be taken against the frost are, okay, so in nature, when the area is when the frost is a common feature in an area, then that area should not be managed under the clear felling system. Okay, so this is a silviculture system. We will be discussing about this in details in the silviculture system lecture. Right now, you just have to remember that the area which is prone to frost should not be managed under the clear felling. It should be managed under the selection system or the shelter wood system. Okay, so in general, in clear felling system, we have we remove all the trees that are present in the area. Okay, while in the selection and the shelter wood system, we remove only, in selection system we remove only the selected trees which we need to remove, and in shelter wood system we keep some trees to provide the shelter for the upcoming regeneration. Okay, so under excessive low temperature after frost, next we have the snow. Okay, so there are some beneficial effects of the snow. That is, snow influence the distribution of the deodar, fir, spruce, and their best forests are found in the place where there is the heavy snowfall. Heavier winter snowfall is essential for the satisfactory and the natural regeneration of the deodar. Okay, snow is the source of the water in the streams and rivers. All the perennial rivers and the streams have their origin from the snow glaciers. Okay, and snow acts as a blanket, prevent further drop in the temperature, and thus protects the seedlings and other vegetation from the damaging effect of the excessive cold and the frost. Then there are the injurious effects of the snow. Okay, so first of all, it is the mechanical bending of the stem and the trees. Here you can see the bending of the stems and the tree, and due to the accumulation of the snow on the crown of the trees result in the breaking of the branches and the top of the trees. Here you can see the broken tree due to the presence of the snow. Here also you can see the broken branches of the trees due to snow. Then the erosion and uprooting of tree due to the sliding snow. Here it is the sliding snow, and here you can see the uprooting of the tree due to this sliding snow. Then the presence of the snow shortens the period of the vegetative growth. The snow favors the growth of some fungi, that is the fomies and the termites. Here you can see these are the fungi which are favored by the presence of the snow. Okay, so under the effect of temperature, we have covered the effect of the excessive low temperature. Okay, so let's study the effect of excessively high temperature. Okay, so the highest amount of the temperature that a species can withstand, it varies from species to species. Okay, so the maximum amount of the temperature that a species can withstand is known as lethal temperature, that lies between 45 to 55 degrees Celsius. Though this is not a favorable temperature to grow, okay, but beyond this temperature, the tree may be die. Okay, the death of the tree results due to the excessively high temperature is due to the coagulation of the proteins that are present in the protoplasma. Okay, due to the excessive temperature, the proteins get coagulated. As a result, the plants do not function well and they die. When the temperature is, even if the temperature is between 35 to 40 degrees Celsius, it may not kill the plant, but it will disturb the balance between the respiration and photosynthesis. Okay, so during the process of the photosynthesis, the amount of energy produced is should be greater than the amount of the energy consumed during the process of respiration. Okay, due to the increase in temperature, the amount of the photosynthesis the amount of the energy produced in the photosynthesis will be less as compared to the respiration. This is because the optimum temperature range for the photosynthesis is lower than the respiration. Okay, so during higher temperature, respiration will occur, but the photosynthesis will not occur. As a result, the energy will be consumed in the respiration is higher than the energy formed in the photosynthesis. The excessively high temperature results in the deficiency of the moisture, and the excessively high temperature result in the excessive transpiration, and this may result in the desiccation of the plant tissue. The increasing transpiration combined with the deficiency of the moisture in the soil results in the death of the plant. The excessive heat sometimes result in the developing of the cracks in the stem due to the excessive shrinking of the outer tissue. This happens particularly with the species which are having the thin bark. And last, we have the heat hardiness. Okay, what is heat hardiness? Certain plants, particularly those which are growing in the hot localities, they are naturally resistant towards the high temperature. Okay, so this is known as the heat hardiness. The important factors that affect the resistance of the plants to high temperature are the water content of the tissue, sugar content, and the acidity content of the cell. Okay, when the water content in the tissue is low and the sugar content is high, this will make the plant resistant against the temperature. While if the acidity of the cell get increased, then it will decrease the resistance against the heat hardiness. Okay, beside these conditions, plants which are growing in the hot regions also keep their lamellae on of their leaves at such an angle that only the margins or the faces
I hope
margins
this
of the
was
leaves
helpful for
faces the
you.
solar
So stay
radiation.
tuned
Okay,
for
this
the
is how
upcoming
the
parts
plants
of this
adapt
book.
themselves towards the high heat conditions. So that's it for today.